Welcome everyone. This is the last tutorial video for the regional analysis course, and in this video I'm going to show you how to calculate the local and the global Moran index in ArcGIS. We write the thematics. We use the Quantum GIS, but ESRI company is offer a free students license for until 31st of August for every university students. So you can download and use at your home the ESRI software. So first of all, you have to download and install the ArcGIS software package, and we will use the ArcMap, the main application, the main software in ArcGIS package. So before the seeing of this video, you should download it. First of all, you have to sign up for the esri.com. You have to register in the website, and you have to find the student's license. And if you have any question about it, we will online in the class time, Wednesday between 10 and 12. So you can ask some questions about the downloading and the installing, but in this video I just want you to show to the method of the local Moran and the global Moran calculation. So what is the Moran calculation? This is the global Moran index. This is the global Moran formula. And this tool is very useful for quantify and measure spatial distribution of a phenomenon. And there are two types of spatial correlation, the global and the local ones. The global spatial autocorrelation, for example, the Moran I index, this is it, gives you a number which shows us the spatial distribution of a given phenomenon. The value shows us that the spatial arrangement of a variable is a random distribution or not. So the spatial pattern is a coincidence, or it has a strong spatial determination. Geographers always looking for non-random spatial patterns. We always find out the patterns, the very clustered patterns, or very dispersed patterns of in the nature and in the society. So if we have a random spatial distribution of a phenomena, we don't have any work of it, because this is in the random case we cannot describe the phenomenon, the degree of a social phenomenon with a geographic with a geographic notion or a geographic location. So we should measure the degree of the clustering, the clusterization, and we should measure the degree of dispersion. So we can look the Gauss curve in the slides, and in the middle of the Gauss curve we have the random distribution. In this case we don't have any work, but in the significant two side of the curve, in this case the red ones, this is a clustering spatial distribution, and the blue one, this is a very dispersed spatial distribution. P value is the probability for the pattern analysis tools. It is the probability that observed spatial pattern was created by some random processes. When the p-value is very small, in this case and in this case, it means it is very unlikely that the observed spatial pattern is the result of the random processes, so we can reject the null hypothesis, which is in this case the null hypothesis is the observed spatial distribution is a random distribution. So if we have a very low number of the p-value, this means we have or a clustered or very dispersed spatial distribution. Okay, and in this case we are looking for some neighboring effect in the distribution, because we are curious about one territory and the surround territories values, which means that those territories which are in the same location has a same value of a given phenomenon, or we have an exception of these territories. But this will be clearer when we use the calculation of these methods. And the local one, because the global Moran I index gives us only one number, only one index, the z-score and the p-value, the probability value. Z-score means the clustering or the disperse the degree of the clustering and the degree of the dispersion in this spatial distribution, the observed spatial distribution. So we have just like the dissimilarity index or the segregation index or the Herfindahl-Hirschman index or the dual index, we have one number, one value for the whole data set. We and this value can describe the whole dataset. But we have a local value as well, so we can find the exceptions and the clustering territories as well in the sample area. How can we do that in the ArcGIS? Open the ArcMap, not the ArcGIS. ArcGIS is the name of the software package. ArcMap is one of the application name within the software package. So we have to open the ArcMap software and add data, and I will upload a package of these files, of these shapefiles. You can download it from the CoSpace database in Budapest, and districts in Budapest we have to add to the map canvas. Okay, we have the used we already used this database for in Quantum GIS, as I remember. This is Aggregates. In Budapest we have 790 aggregates in Budapest, so this is a very good resolution for the spatial distribution of social phenomena. And we have districts in Budapest, the official administrative areas within Budapest. So the visualization to the visualization of these districts borders, grab and drop at the top of the table of contents, and double click of the layer, and left click on the symbol, and you have to change the fill color to the no color, and change the outline width to 2, and change the color to black. Okay, and okay, and this is it. This is the borders of the official administrative areas, and we can open the attribute table of the database in Budapest with right click to the layer and open attribute table, and we have a lot of values, a lot of social phenomena, spatial distribution for the aggregates, and the last column we have in the last field we have a higher education ratio, which means how many percentage of the total people, how many percentage have some kind of degree, some kind of diploma in each and every aggregates in Budapest. So we are curious about the spatial distribution of the percentage of the diploma, the higher education ratio. To find the clustering, the degree of the clustering of this phenomena, we have to use the Arc toolbox in the menu bar. If you don't have any kind of them, we have to choose spatial analysis. No. Tools, no. Standard. Yeah, right click and click the standard, and this is Arc toolbox. Left click on that, and in the spatial statistics tools analyzing patterns, and we have a spatial autocorrelation tool for calculating the global Moran I index. So double left click to the spatial autocorrelation Morans, and we have to select the database in Budapest, and input field will be the higher education ratio, and click on the checkbox, the generate report, and not the inverse distance. We are curious about the fixed distance band, and Euclidean distance is fine for us to this calculation. Okay. And we cannot see anything, but if we just click on the geoprocessing and results, we have one spatial autocorrelation Morans, and if you just unpack it, we have a report file, and just double left click on it, and we have the report file for the higher education spatial distribution. We have z-score 69, and this is a very, very clustered value. So this means the higher education, the spatial distribution of the higher education has a really clustered spatial arrangement, spatial distribution, because above 2.5 this is a really strong, but we have a 69 z-score, so this is a very, very high clustered phenomena, and this is significant because the p-value is 0, unlikely to random spatial distribution of the higher education spatial distribution. Okay. And for the result of this task, this HTML file, so you have to find this folder, and you have to upload back for us in the CoSpace this HTML file, so prove that you just calculating the global Moran index. After that, we have to calculate the local Moran index, and click on the R toolbox in the under, and in the spatial statistics tools, mapping clusters, and the first one, the cluster and outlier analysis, local Moran ones, and click on with a double left click, and input feature class is database in Budapest. Input field is also a higher education, and for the output feature class we have to change and make a new shapefile for the result file. Type higher education spatial distribution, for example, and shape. You have to type the shapefile sign for the for after the name, because ArcMap, because of that characters, know that file has a shape file. Okay, and and also not an inverse distance, fixed distance band. Okay, and okay. We have a very very colorful map, but we have to colorize with another colors, but grab and drop the second. We we have to look at the borders and the high clusters. Double click on the black color and change the fill color for a medium coral light. Okay. High low cluster, we have to change the color red, Mars red, or a really hard red one. Okay. Low high cluster, we have to change a hard blue. Okay, and low clusters, we have to change light blue color. Okay, and not significant and very really light gray. So this map shows us the clustering of the higher education, which means that in the at the Buddha side we have a very high percentage of the higher education, really high percentage of the higher qualified people, and in the downtown we have also really high percentage of the higher education, but the hard red ones means that there is a really high percentage of the higher education people, but surround them this is a very low there are very low higher education ratio, so this is exception of this territory. This is an exception, this and this and this is also an exception in this territory, but we have also another exceptions. In the 8th district we have a very hard blue one territories, the hard blue aggregates, which means that this is a very low percentage of the higher education ratio, but surround them, surround these territories, we have a really high percentage of the educational level. This means these are the territories which is you've heard about these urban geography phenomena notion. This is a very key territories of the gentrification areas, which means that the gentrification areas are very dispersed and living each other neighborhood, living the very high percentage of the higher education and the very low percentage of higher education. But there is another one. This is a new flat of houses, new gated community in the very low educational level area. So this is a higher educational level island in the very low and low qualification people. So with these two we can show the clustering territories, the high values clustering and the low values clustering territories in any kind of observational area. So, for example, your observational areas in the thesis or in your presentations of your home countries, you can measure and you can calculate these measures for your home countries, some kind of subdivisions, the higher educational levels, or the employment ratio. This is a tool for a very useful of any kind, to measure any kind of the social phenomena's spatial distribution. Okay, and for the result, because this is a result, the shapefile is a result, of course, but in the global Moran, the HTML file, the result, but in this case, the map is the result, the necessary result for the so you have to upload back in the code space and in the second test also. So change the view from data view to layout view, and we have to make a map similar as the quantum GIS, but some kind of different. So click on the editor layout. Not draw. Draw, yeah. Click on the map canvas and properties, size and position, and 0, 0, and 30, 30. Accept and OK. And click on the file, page and print setup, and click on the checkbox and width 30 also and 30 also. And in this case, the scale is 200,000. No, that's not enough. Not enough. So 110,000 will be the scale, and if the map not in the right position, no. Where is the layout? But where is the not this pen? No. I'm just looking for data frame tools. No. Sorry for that, but labeling, no. So I can find in the tools. Uh, yeah, in the tools we have a pen, and with this tool we can just grab and drop the map within the frame. So, and after that uh, we can insert a legend, for example, uh, but we don't have to all of the legend items, just the districts in Budapest and the higher education spatial distribution, and accept. Okay, okay, okay. And just rewrite uh, districts of Budapest, and this is fine. This will be fine. And after that, text spatial distribution of higher educational level in Budapest. Okay. And double left click, change symbol. Yeah, and size will be 28, for example, and bold. Okay. Okay. And in this case we have to use the pen. Okay. And very necessary element, the source, central statistical office, census of 2011. Double left click, we can modify it in the properties as well. Editor will be your name, Tamás Kovalcsik, and the date via ArcMap. Okay. Okay, and change symbol. Okay. And we can also insert a scale bar, for example. But with not miles, because we use kilometers. And number of subdivisions, we don't need any subdivisions, only kilometers. Okay. Okay, and we can insert north arrow as well. And this is it. And after that, file, export map, and we have to find our folder. Higher education level BP, for example. Save, and save the project as well. And this is a very useful to open at any time this project for example, and save. And you have to just upload back the PNG file and the HTML file in the CoSpace, and the second test as well. So thank you for your attention, and if you have any questions, you can ask us in the Discord server in the time of the class, Wednesday between 10 and 12. Not 12, 20, yeah, 12. And you can ask us after that the CoSpace and in email as well. Next week will be the, as I remember, in the next week will be the second test. So have a good preparation for the second test. There will be weighted Gini and Lorentz calculation, also correlation and regression analysis, and you have to make one global Moran and one local Moran analysis in ArcGIS in the second test. So have a good preparation and have a good time. Bye.